All right, in this video we're going to investigate this function and we're going to figure out where the infinite discontinuities are by using limits. All right, so the first thing we're going to do is we're going to look at this problem. It says to determine the limit as x approaches -1 from the left of h of x, first use direct substitution, right? We're just going to plug in -1. So let's do that. So h of -1 is going to be -1 squared minus 4 all over -1 plus 1 and -1 plus 3 squared. Okay, so that is going to be -3 over 0. Well, that's a problem. And then that's going to be 2 squared, so that's going to be 4. So the denominator effectively becomes -3 over 0, but here's what we need to think about. Is that 0? Because it's not actually 0 when you go back and consider you want to calculate the limit as x approaches -1 from the left. You want to determine, okay, if I put in something slightly smaller than -1 right here, this piece that becomes 0, will that produce a negative number that's extremely close to 0 or a positive number? If we're plugging in something that's slightly smaller than -1, that 0 is not actually 0, it's a number slightly smaller than 0. So that's actually a negative number. So this is almost 0, but not quite. It's slightly negative, but extremely small. So when we do -3 divided by a negative number that's extremely small, that's going to blow up to a positive infinity. So this is going to be the result of this value right here, this limit. Now, when we calculated this, when we put this in, we got -3 over 0, which is undefined. Okay? So what we're going to do in this problem is we're going to have to consider those zeros and determine if they're slightly positive or slightly negative. So I've kind of prepped for this problem. I've done some of the work they're asking you to do. Let's read this for a second. Anytime you get any non-zero number divided by 0, then your limit will either be a positive infinity or a negative infinity. So these are the things we're looking at for, because here we had a negative number divided by a 0, and our result was an infinity. So our result matches what they're saying it should. Okay, we're going to mark the x values at which h is a 0 or undefined on a number line. H is 0 where the numerator is 0, and h is undefined where the denominator is 0. So I've done that down here. Our zeros are at 2 and -2, because when we look at this function, the numerator was x squared minus 4, so we get the zeros of 2 and -2. And then the denominator has factors that are x minus 1 and x plus 3, so the zeros there for the denominator would produce the undefined values. All right, so we've got our number line marked, and I've marked these essential numbers, and 2. And 0 and 1 I just put there because I like to have all the numbers on a number line if they're not too far apart. Okay, which interval of x values do we need to study in order to determine this limit? The limit of h of x as x approaches -1 from the left. We really only need to look at this interval because we're approaching -1 from the left, and that's what we did up here when we were looking at this almost 0, right? That almost 0 has to be negative because we're approaching -1 from the left. So we've already done that piece. Okay? All right, so we figured out that this value has to be a positive infinity because we got -3 over something that's very close to 0 but negative, so that's going to produce a positive value, but it's not an actual value, it's an undefined, it's a vertical asymptote, and we're going to get a positive infinity. Okay, we're going to use a similar argument to determine the following. We're going to show our work as we go through. I kind of talk through it. So now we're going to approach -1 from the right. So we're going to go back to what we did up here. We're still plugging in -1, but I am going to change this right here. We're going to change that to a positive. So we need to go back here, and we're going to have to rethink some of this stuff. So let's go back and rethink our zeros and see what our result happens to become. So we're approaching -1, but now from the positive. from the positive side, okay? So like negative 0.9, negative 0.99, negative 0.99999. And when you add 1, that 0 will always be slightly positive. So now this number that's almost 0, not quite 0, it's a positive number. That is really the only thing that changes in this problem. So now we have a negative divided by a positive, which gives us a negative. But since that number is almost 0, it's not quite 0, we're taking a negative 3 and dividing by something extremely small that's positive. A negative divided by a positive is a negative, and it's going to go to infinity. So we have effectively evaluated this one, negative infinity. So if we look at a graph, what we should see on a graph is a vertical asymptote at -1. And I happen to have a graph here. So if we go to -1, you can see we have a vertical asymptote at -1. As we approach from the left, we are going to positive infinity. As we approach from the right, we are going to negative infinity. So the graph matches what we are doing analytically. All right, let's do the same thing for -3. We're going to approach from the right and from the left. So let me get rid of some of this stuff. Since this problem up here that I did in blue, this was for approaching -1, we're going to do a new one down here, and we're going to look at what happens to this function as we plug in a 3. And then we're going to have to determine from the left and right. So we're going to look at x squared minus 4, but now we're plugging in -3 squared minus 4 all over -3 plus 1, -3 plus 3 squared, right? And we're going to look at what's happening to this. So we get 9 minus 4 in the numerator, and in our denominator we get -2 and a 0 squared. Now, this is actually really good because anytime you square a number, this almost 0 is just going to be positive no matter what. Because if it was a negative almost 0, and we squared it, it would now be a positive almost 0. And if it were a positive almost 0 and we squared it, it would also be a positive almost 0. So we're looking at our almost zeros, and it doesn't matter if we approach that -3 from the right or from the left, if we're doing this or this, our denominator is always going to be a positive almost 0. And our numerator is going to be a 5. So a positive divided by a positive is always a positive infinity. So both of these are positive infinities because that denominator is going to be 0 whether you approach from the left or the right. So if we look at -3, we should, oh, do I have something wrong here? Let's see what's happening here. Oh, I see what's wrong. This is our error. This should be incorporated into our problem. So when we have a positive 0 and we multiply it by a -2, we have to take both of those things into account. I got excited. So a negative times a positive is going to fix this. And let's think about this again. All right, rewind, replay. We've got 5 in the numerator still. When you multiply by 0 in the denominator, you get an almost 0. This almost 0 is always positive, but when you multiply it by a negative, you're going to get a negative. And that's why we get the negative infinity. And that's why you should verify things graphically, because you will find your mistakes and then you will understand why. So you can see now in this graph that we are going to negative infinity from the left and the right of the -3. All right, so I made a mistake for you. I hope that's helpful because you guys often make the same mistake. So I was just modeling that for you. All right, you guys, I hope this helped. I will see you in class.